Okay, so this is vectors question 4. First thing I've done is I've actually labelled the shape as much as I possibly can. Because these are parallelograms, this is a parallelogram here. That means if that's A, that's A. This is a parallelogram here. So if this is B, this is B. Okay, and this is a parallelogram here. So if that's A, that's A. Now, the first one we've got here, OD, O to D, that's going to be plus B plus A, plus B plus A. And if we write it round the right way, that's A plus B. The vector journey is OB plus BD. The next thing we've been asked to find out here is OC, O to C. The easiest way to do it is to use the vectors that you have at your disposal here, which is OB, BD, and then DC. That's B plus A plus A. B plus A plus A, which we know is equal to 2A plus B. You must write it in this simplified form. The next thing we're going to look at is part 3 here. Now part 3 is AB. Now let's have a look at AB. That is from here to here. We can see that is going AO plus OB. Now AO is minus A, and this is plus B. So AO is minus A, and this is plus B. So altogether we have plus B minus A. And that's the vector journey, and these are the vectors added up, and there's your answer. Okay, now part B says the point F is such that OCFE is a parallelogram. Write down the vector CF in terms of A and B. So OCFE. Now we haven't got an F on our diagram, but we have got the others. So if we just mark what we've got here, O, C, F, which we don't know, and E. Now if I mark this in, we can see that F must be somewhere up here. That's where F's going to be. It's going to be somewhere up there. Now the first thing we need to establish here is we need to establish what is OE. Because if we work out OE, OE will be this vector here, which will be the same as this vector here. So let's work out what OE is. To do OE, we go B, A, B. B plus A plus B. That is 2B plus A. So therefore the vector CF will equal the same thing. So the answer for this last bit here is 2B plus A. And what is the geometric relationship between the points O, D and F? O, D and F, I'm guessing here that they're talking about that they would be collinear. They would all sit on the same line. Collinear. All sit on the same line. And to prove that, what you have to prove is that OF, which is 2B plus OF, which we need to find out, is going to be a similar type of vector to OD. it needs to be parallel. These need to be parallel. Okay, so we know OD we worked out earlier is A plus B. We need to work out what OF is. OF, I'm going to use my diagram for that. OF is B plus A plus another A, and then the vector CF. So I've got actually the vector OC and the vector CF. So OF is equal to OC